Okay, welcome to day 3 hint videos. Here, we're trying to solve by elimination. Elimination means just what it says. We're going to try to eliminate one of the variables so that we can just get one variable and then solve for that single variable. And then we can plug it back in using that substitution and find out what the other variable is. Right? So, the way that you eliminate them is by stacking them on top of each other, and then we want to add them together in such a way that one of them will drop out. So like we want to have opposites on the coefficients there. So like example, so 4p, I want to have a negative 4p here to be able to cancel it out. So how do I change that into a negative 4p? Well, I could just multiply both sides of this equation by negative 2, right? So let's just multiply the whole thing by negative 2. That makes it negative 4p, negative 4d, and then negative 2 times 7 is negative, this is going to be negative 13, no, 15. Okay, and then you can add this first equation to this second equation, and when you add it together, this will cancel out. 4p minus 4p is 0, and then d minus 4d is negative 3d, and then you would get a solution there. So you have negative 3d equals negative 15, and that'd be like negative 4.5, something like that. And then you could solve for d from there, and then you take that d value and you plug it back in to either one of those equations and find out what p equals. Now, just to kind of step back a little bit and talk about the concept, this value is equal to this value, right? So it's like if I had, 3 is equal to 3, and then if I add equations together, so now this other equation says something like, I don't know, 4 is equal to 4, and if I multiply this whole equation by negative 2, then it turns into negative 8 equals negative 8, right? And then if I add those two equations together, 3 plus negative 8 would be negative 5 equals negative 5. So see, this final thing that I got over here, it's still a true statement, just like this is a true statement. See, I didn't break any mathematical rules by multiplying that whole equation by negative 2 and then adding the equations together, because doing that doesn't disrupt any mathematical rules. I can multiply both sides of the equation by the same quantity, and I can add some things that are equal to both sides, right? So I'm adding, in this case, I'm adding 3 to both sides of this equation, and I get negative 5 equals negative 5. Here I'm adding basically the value of 10.5, although it looks different on this side, doesn't it? But this whole thing has a value of 10.5, so I'm adding 10.5 to both sides of this equation and getting a new equation that is also true. And then I can modify this equation to find out what d equals. And then I can take that value and plug it in and find out what p equals. Okay, so that's what elimination method's all about. Just a little hint to get you started. You will have a couple equations to write and putting together your own solution and so on. So you will come up to a point where probably the elimination method means that you don't have to just multiply a single equation by to get that elimination. Let's see. All these I think you can handle with that idea. Okay, I just wanted to do one example where they wouldn't actually eliminate if you only multiplied one equation. See, I mean, I could multiply one equation by, I think it's 3 halves, right? I can multiply this equation by 3 halves, but then I introduce a fraction, and that might not be what I want to do. So it's kind of like finding a common denominator. I could say, well, let's make this a 6 and this a negative 6. So I'm going to multiply this whole equation by 3 and this whole equation by 2. Then it would turn into a 6 and a negative 6. So what you want to do is find a variable that you can eliminate by kind of doing that common denominator thing. So you think what do I need to multiply this by and this by to make them cancel each other out so that there's a positive and a negative there. And it may be that if this was a positive, then I have to multiply by negative 3. Okay, so I'll just write this out. 6y equals 12, and then this new equation is 15x minus 6y minus 9. And then I can add them together and see now I get 19x equals 3. And so this one is kind of, I didn't make up this I made this equation up off the top of my head, so it comes up with a strange answer, but this is 3/19 would be the value of x that would make this statement true. Then I would plug the 3/19 in and find out what y equals. So it's going to get pretty messy, but this is the general procedure that you would do to solve for a single variable using the elimination method. So that's how it works.